First of all, solar energy systems vary depending on application and size. Residential systems are found on rooftops across the United States, and businesses are beginning to install solar panels to offset their energy costs. Utilities, too, are building large solar power plants to provide cleaner energy to all customers connected to the grid. Regardless of the specifics of a given installation, the main type of solar energy technology is photovoltaic, PV, and the other one is concentrating solar power, CSP. But most people are familiar with PV technology because of the solar panels they see more and more on the tops of buildings or ones placed on the International Space Station. When the sun shines onto one of those solar panels, photons from the sunlight are absorbed by the cells in the panel, which creates an electric field across the layers and causes electricity to flow. PV installations may be ground-mounted, rooftop-mounted, or wall-mounted. They may be mounted in a permanent orientation to maximize production and value, or they may be mounted on trackers that follow the sun across the sky. Rooftop PV panels make solar power viable in virtually every part of the United States. In a sunny location such as Los Angeles or Phoenix, a 5 kilowatt residential system produces an average of 7,000 to 8,000 kilowatt-hours per year, roughly equivalent to the electricity usage of a typical U.S. household. A solar cell is made up of silicon, which is one of the most common elements used as a semiconductor along with germanium. A solar cell is one perfect example of a single p-n junction comparable to a photodiode. As shown in the figure, the n-type silicon side of the panel is what is exposed to the energy coming from the sun, causing an electron to flow going to the p-type side of the cell. On the contrary of what has been taught to us, that current flows from the positive side to the negative side, which is called the Hall flow. The flow of charge in a solar cell is based on the electron flow, which is from the negative going to the positive. This flow of current is called the electron flow.
The vast majority of solar panels are made of silicon solar cells with some copper for the wiring, some aluminum for the frame. There are no toxic chemicals in there. So what's silicon? Silicon is dirt. Sand is made of silicon dioxide. It's a very common thing. In fact, silicon is the second most common element in the Earth's crust. All of your electronics things, all of your computer chips are made of silicon. We have brought the manufacture of silicon to a high art. And it is, so it's common, it's not toxic. The other things in the solar cells are not toxic things. What does it do? It converts light to electricity. That's all it does. It's a very simple device. In fact, it's the simplest semiconductor device. It's a single p-n junction. Whereas, compare that to your computer CPU. Your computer CPU probably has 500 million p-n junctions in it. It's a very complicated semiconductor device. So solar cell, very simple. Light goes in, electricity comes out. So in the industry here, this is a couple of graphs about that. The growth in installations, this is just for the United States. Of course, there's been growth in the residential, and non-residential is like small commercial and industrial. So there's kind of four sectors. There's the residential, put solar panels on your house. There is the small commercial, like your local small business that has maybe 50 to 100 kilowatts of solar on their roof that is powering their business. We have a hardware store in Endicott that has, I think they have 100 kilowatts up there. And not only do they power their store, but they actually have someone, I think they sell some to somebody else too. So that's kind of the small commercial. Then there's the large commercial or industrial, where you might have a factory that has solar cells on it, that has solar panels on it, that is running part or all of the factory. And then there's the utility scale. So utility scale, where you are building hundreds of megawatts out in the field. And there's quite a few of these now. There's getting to be more every day, especially out in the Southwest. Southwest has a lot of sun, but they also have a lot of physical space to put the larger systems. For a larger system, you also have to have a good grid, because you are going to need to move that electricity from where you're generating it to the users. So in 1977, a 4-watt solar cell, which is something this big, in 1977 cost $300. Today, that same thing costs $1.20 up there. It's probably a little less than that now. So that is the effect of mass production. Another nice feature about photovoltaics, about solar panels, is they're very durable. In some ways, it's a lot more durable than wind as far as, it doesn't need as much maintenance. Not zero, but it doesn't need much because there's no moving parts. It just sits there and converts light to electricity for years and years and years.